Hello everyone, welcome you all. So in this video we are going to discuss about how we can use the Zener diode as a voltage regulator. So first we'll see what is meant by voltage regulator. Suppose there is a device something like fan, so it wants a constant voltage to be supplied. So when we rectify the voltage, it consists of peaks, right? So these are the pulsating DC, so it contains some part which will be returning to zero and again increasing. But the smooth DC is something like this, a straight line parallel to the x-axis, so there are no fluctuations in the voltage. So these type of voltage is needed for the working of DC components, so this is not desired. So in order to convert the pulsating DC into the smooth DC is called as voltage regulator, or we should have constant voltage there. So in this case what is our, so this can be done with the help of filter. So in this case the Zener diode is used as a voltage regulator. Suppose the voltage is fluctuating between 2 points A and B, but we want a point which is B by 2 constant. So with the help of Zener diode we can maintain the voltage at this point. Though the input voltage increases between these points, it will, suppose it is initially at the point A and it increases to point B and it keeps on fluctuating, but with the help of Zener diode we can maintain the output voltage at the level B by 2. So this is what is called as voltage regulation. So maintaining the output voltage at the constant value in spite of changes in the input voltage. So what the circuit consists of is V in unregulated voltage. So here is the unregulated voltage that is given to the circuit, then a load R is connected, then a Zener diode is in shunt with the load. So shunt means it is connected in parallel with the load, right? So IZ current flows through the Zener diode and IL current flows through the load current. So IL is the load current and IZ is the Zener diode current. So VZ is the voltage across the Zener diode and V0 is the output voltage or voltage across load. So the Zener diode has a characteristic that as long as the current through it is between IZ minimum and IZ max, the voltage across it is constant equal to the Zener voltage. So if you have seen the characteristics of a Zener diode in the reverse characteristic, so this is something like this, right? So this is the VZ voltage and this is the minimum current IZ minimum and this is the IZ maximum current. So as long as the current is between IZ minimum and IZ maximum, the output voltage will be constant, that is VZ or breakdown voltage. So this is the speciality of Zener diode, where the in spite of changes in the current, the output voltage will not change. It will be at a constant voltage called Zener voltage and it is denoted by VZ. A Zener diode is connected in shunt with the load resistance. The output voltage is equal to the Zener voltage. So the output voltage and Zener voltage are equal because it is those are connected in parallel to each other. Therefore R is equal to V in minus VZ by I. So resistance R can be given by input voltage minus output voltage divided by current flowing through it, that is I. So that is I equal to V in minus VZ by R we can write. So the relation between various currents is given by I equal to IZ plus IL. So I is coming at this node and this is splitting into two parts. So total I will be the sum of IZ and IL. So that I have written here. Now in second case, when regulation with varying input voltage. So when the input voltage is varying and we want to regulate the output voltage, so how we can do with the help of Zener diode, so that will be seeing here. So in this video, so in this circuit the V in voltage is varying, so the other components are same, that is resistance, Zener diode and load, and the current flowing through the resistor is IL and the current flowing through the Zener diode is IZ. So output voltage V0 is equal to the Zener voltage VZ. So the output is constant, that is V0 equal to VZ and IL equal to V0 by RL. So IL will be equal to V0 divided by RL. So that is I equal to V by R formula. So that will be equal to VZ by RL as V0 is equal to VZ. So this is constant. And also I is equal to IZ plus IL. Here if V in increases, then the total current I increases. So if V in increases, the total current I will increase. but IL is constant. As Vz is constant, hence the current Iz increases to keep IL constant. So if I increases, then as IL is constant because it is the current flowing through the load, so in order to compensate that one, Iz also increases. So I increases, Iz increases. That is current through the Zener diode increase because IL is constant here. But as long as Iz is between Iz minimum and Iz max, the output Vz is output voltage is constant. So in the characteristics, as we have seen, so this is the Iz minimum and this is the Iz maximum point. So this is the breakdown voltage Vz. So Iz increases, so Iz will increase from this point to this point, this point to this point. So as long as it is between these 2 points, the output voltage Vz is constant. So that's why if Vn increase also, there is no a change in the output voltage, that is V0. So like this we will be getting a regulated voltage for the varying input voltage. So this is the case for varying input voltage. Now regulation with varying load. So what happens if the output load is varying? So here the input voltage is constant while the load resistance RL is variable. So load resistance RL is changing here. As Vin is constant and V0 is equal to Vz is constant, then for constant R the current I is constant. So as R is constant, so I equal to Vin minus Vz by R we can write, so which is equal to constant, so which is given by IL plus Iz. Now if RL decreases, so IL increases. So in order to compensate the total current, if RL decrease, IL will increase because we know that I equal to V by R. So if RL decreases, then IL has to increase in order to compensate for these two. To keep I constant, Iz decreases. So Iz will decrease, and but as long as it is between Iz minimum and Iz maximum, output voltage V0 will be constant. So as I have shown in my previous graph, so as the output current, that is Zener current, is between Iz minimum and Iz maximum point, the output voltage will be constant. Similarly, if RL increase, so as IL decrease to keep the I constant, so Iz increases here rapidly. But as long as it is between Iz minimum and Iz maximum, output voltage V0 will be constant. So like this, if the output load varies also, we will be getting a constant voltage across it. So this is the use of Zener diode as a voltage regulator. So if you like the video guys, please hit the like button and subscribe the channel for more updates.